All kinds of things going on here. We're live. It's 8:59, right before 9 o'clock. Hopefully you guys are all doing well. Project motivation time. It's Friday, coming into the weekend. Lots of time to get stuff done. So get out on the weekend. Get up early. It's terrible, but get up early. Get up an extra hour early and get something done for an hour. You can always go back and sit on the couch, lay down, have a nap, whatever, later on. But you will feel better if you got something done in your project. Got the wiring done, got some headlights installed, got the new ring and pinion put in, got the contact pattern all done, gapped your rings. That's a little bit of work, but all of that stuff is good stuff to get done. I'm going to try to get some more stuff done on the 396 this weekend. I have some cleaning to do because I've got some overspray on it. I'm going to try to get the lifter valley done and then try to get I think I need to order some rings for it. I don't think I have rings for it. So I've got to get those gigantic 5/64 rings that they used back in the day. I think we'll use some Hastings or something probably for that. But I'd like to get that thing all together, or at least get a short block done. That would be kind of cool. I've got some other things. I've got to put the freeze plugs in and stuff as well. So hopefully we'll be doing that. And the poll for today is, if you've seen the thumbnail, okay, so today we're going to talk a little about intake manifolds. And if you take a look at the thumbnail that I have up, I've got two different iterations of what is essentially the same intake manifold. So that's a 462 valve, and it's the Super Ritchie adjustable intake manifold. Two individual plenums, one for each bank of 4-cylinder, basically. I also ran them connected and unconnected and all kinds of stuff. But the difference that I want to talk about today is that you see on one of them, we actually made them angled out. We put a curve in it and then put our extensions going outward. And then also I eventually cut those off and then made the tubes. We welded onto this started out, I think, as this started out as the lower flange for a truck intake manifold, I think it was. I think that the truck manifold had an aluminum base on it. It was either the 542 valve, or it was a 462 valve that had had an aluminum base. And so we used that and basically cut it off, and then put our tubing on it and welded our tubing onto that base, so that the base could also still have the provisions for the injectors and stuff. And then we could make our thing adjustable from there. But the question for today is, one of them basically goes straight down into the head port. The other one goes at an angle into the head port. It has a slight turn right before the entry, right for the transition from the intake manifold to the cylinder head. So the question is, which one do you like better? Would you pick the straight version, straight down into the head, or would you pick the curved one, assuming that they're identical runner lengths and plenums, because all of that stuff is shared? So which one of those would you pick? So that people know, and I don't think this will affect the poll at all, the reason that I wanted them to be straight is it just made it a lot easier for me to do the adjusting on them, because it was at an angle. As we did it, everything got farther away from each other. So when I did the connection tubes, those had to be longer, and then we had to have multiple lengths of that stuff. But when I went straight down, the connection tube between the two plenums, whether we wanted it connected or not, we wanted to test it both ways. But that connection tube would be the same no matter what the runner length is. So it made testing a little bit easier, rather than having to have. And then we were also changing, every time we changed runner length, we were also changing plenum volume if they were connected, because we had more of a joiner tube in between those two. So we wanted to keep that part consistent. again, we're we're picking nits there, but it really, I did it just so that it would facilitate doing all the testing. It made it easier. So which one looks better? which one um, which one makes more power? Does the bend in there, does the curve? Because as we know, I'm sure all of my intake designers are going to tell you the it's not a theory, it's actually a fact that as you add a certain number of bends, that it changes the flow rate or drops pressure by a certain amount, and yada yada yada. And while all that may be true, the real question is, how does that actually affect power? And does it actually affect power? What happens, for instance, if we have a situation where we have an intake port where we have a motor that's only using 2/3 of the flow of that intake port anyway? So if, let's say, we have an intake port that flows 300 CFM, but each cylinder is only using 200 of that, does the bend make any difference? And I can tell you, so that people are wondering, that the reflected wave doesn't care about a bend. It has no effect on that. That's only length. So it will go through, as we've seen, if you take a look at any of the production, like the production PI intake manifolds, a perfect example, or any of the LS or any of the Hemi, any of the Coyote stuff. It's all of the ones that are designed basically to flow air have all kinds of turns, not only mostly because of packaging, but also they want the reason that they are the way that they are, and with the reason that they cross over and double back and do all this stuff is because they want the runner length to be correct for the RPM range that they're running. And they would rather do that and go through the packaging problems. They would rather have the runner length and have the bends, because it's the reflected wave is not as affected by that. Flow is. It is. But the question, that really isn't the question. And that's an important thing that we talk about in these live feeds, and that's that you may be answering one question, but you're not answering the big question. When we start talking about little things like should I port, when we talked about porting heads for a turbo LS, well, should I port the head? Well, porting the head will make more power. So on the surface, you could say yes. If you port the head, you'll make more power. And the next step above that is, if you port the head and it makes more power, then you'll be able to make more power at any pound of boost. That's also good. So you got two steps that are saying yes. But that's still not the real question. The question is, how much power do you want to make? Do you have a turbo that will already do that? And can you do that with your existing heads without having to go through either the expense of buying ported heads or new heads, or doing the work yourself if you are qualified to do, can you port it and do the things that, aftermarket CNC programs, from the various companies, can you do the kind of work that they do to get the kind of power gains that they get? And then, like I said, is that even necessary? Same thing with camshafts. Well, should I put a bigger camshaft in when I'm running a turbo motor in my Dodge or my Hemi or my LS or my Ford? Well, if you put a camshaft in it, it will make more power. And it's the same thing as the head. It will make more power. And if you're running boost, you make more power NA, it will make more power at every given pound of boost. You'll make more horsepower per pound of boost. But that's not the real question. the question in a camshaft is even different than it is with cylinder heads. So the question with the camshaft is, not only can I make the power with my 1,000 horsepower turbo or my 700 horsepower turbo, will it still do that? But also, should I look at a smaller cam, because I can still make that power, plus I'm getting better drivability and fuel mileage and boost response? I can possibly get that with choosing a smaller cam rather than the bigger cam that would ultimately make more power per pound of boost, but I'm going to get everything out of the turbo anyway, so I'm not really concerned about that. So the big question is very important. And that's why I like to start with, this whole channel is basically designed around this fact. I try to cater the stuff that I do to the vast majority of people. I don't care about, I mean, I care about, but engines for pro mod racers and that kind of thing. That's not my deal. That's not what I'm doing. I want to provide information and data and testing so that the average guy can make good decisions. But before they can make good decisions, they have to ask the right question. So the first question is, if you have a turbo combination, whether it's a small block Chevy or an inline 600 or whatever it is, how much power do you want to make? What's the thing? What do you have to do? Well, I want to make as much power as possible. No, you don't want to build a top fuel motor. It's not very fun. Well, it'd be very fun, but it'd not be fun to go fill up at the gas station, and it wouldn't be very drivable, and it would have lots of other problems. You don't really want that. And especially if you're young or new at this and haven't done it a whole bunch of times, you probably don't, and especially if you don't have the driving talent, you don't have the tuning talent, and you don't have the rest of the car to go along with that, because making 1,000 horsepower is so easy now that, do you have 1,000 horsepower brakes? Do you have 1,000 horsepower driving talent, or 1,000 horsepower transmission, or all the other things that have to go along with that? So you should make sure that, again, that you're asking the right question. What should I do here? And we tell people that all the time. Look, you can, and we have guys in here that have done this, made the mistake of rushing out and turning the boost up and hurting something. And you shouldn't do that. You should start out with less boost. You should start out low. And we do that when we're tuning. We start out with less timing. We start out with more fuel. We start out with less boost. And then make sure everything is right, because there's no hurry to turn the boost up. There's plenty of time for that. When everything is right, that's when we do it. So we start out at whatever the lowest boost setting is. We start out with a wastegate at 7 pounds and no timing and plenty of fuel. And then make some runs. Oh, it's 10-1 and it only has 15 degrees of timing in it, so it can't possibly hurt itself. Okay, the motor seems okay. There's no leaks. There's no weird oil thing going on. There's no stuck injector. There's no not flowing injector. There's no weird timing anomaly. There's no, temperature compensation. There's none of that stuff. None of that's going on. Everything's happy. Okay, now that we know everything's happy, let's put some more timing in. Oh, hey, look, 2 more degrees. It loved that, as they always do. And then once you get up near, 20 degrees or something like that, hey, it's like really, really happy. It really wants to make power there. Yes, it does, and it will continue to do that. And then, and especially with timing on the tuning thing, don't keep looking for more. If it's working, just leave it there. Oh, should I go from 20 to 22 and 24 degrees? No, you shouldn't. Even if you gained more power there, especially with boost, that's not where you look. Look at another pound of boost before you look at another 2 degrees of timing. That's not the trade-off that you want, because 2 degrees of timing could definitely make or even 1 degree can make the difference between it running and not running, and you blowing something up. But if you have safe timing and you add a pound of boost, probably going to be pretty safe. Again, the big question, what is the big question? Let's see how our poll is doing. Would you pick the straight intake design over the curve? 73% are saying yes, and 27% are saying no. So there's an interesting thing we'll talk about in a little bit about that particular intake manifold. If you haven't seen it before, I've had interior shots of this thing, of this plenum. This plenum has full radius, like bell mouth air horns inside of it that are stood off from the plenum floor. Each one of them has a 75 millimeter throttle body, which is usually one 75 millimeter throttle body is enough to support the airflow of your typical 462 valve. Although I did have one that made nearly 500 horsepower NA. It was using this manifold, but not this runner. Like, this much shorter than this. But having two, as we know, it has to be better, right? But on the intake manifold, here's something else to think about, and this goes in line with us asking the right question. So the question is, for the poll, is would you take the straight entry into the head versus the curved entry? When somebody asks you that question, the other question that you should be asking, and maybe somebody has in here, I haven't read the comments yet, The question you should be asking is, what is the angle of entry on the head port? So what direction is that going? The flange is flat on the head because the intake manifold basically bolts straight down to it, kind of like a Hemi does. But the intake port is actually at an angle. So the head flange is like this, but the head port is like this. Is at an angle. And then we're coming straight in like this from the intake manifold, or we're coming curved like this. So now, is it better for the airflow to follow a nice smooth arc that makes a turn into the port? Actually, and this is what people should be commenting about, this design would be much better, or would be optimized. It'd be optimized first if the head was flanged at a different angle. It would be the angle of attack would be better, not straight down and then immediately turn. Or if the intake runners were a cross ram and came in, the intake runner came in at a straight shot essentially into the head. The way that they have the thing flanged, that's a little bit harder to do, but that would be ideal. Then it would be a straight shot. The intake would be a straight shot to the valve, which, as everybody knows, that has to be the best way. Even though that's very, very hard to do on a lot of applications. Some of the heads just don't lend themselves to that. The small block Chevy intake manifold for a stack injection or a big block is an example of that too. They almost always make some sort of turn going in. But if it were straight in, like a good example of that is the Honda IR system that I did. Oh, I didn't do it. TWM did. The one that I did had we were testing the positioning of the injectors on that. And that worked out very well. But that's essentially a straight shot into a 4-valve layout for that cylinder head, and it worked. And it works very well. And then especially if you can argue about tapering that and having all that, and that works good. But the question on the thumbnail is which one of those is better now that you know that there's a change in direction in the port of the head anyway. These are some of the problems that are associated with this 462 valve layout, and why it doesn't they don't usually make a ton of power. If you look at if you were to just measure the cross section of the opening of the cylinder head, it's actually pretty big, except the problem is that it's only that big there and you can't make it that big the whole way. And you can get these things to flow. If I remember right, goes way back, but I think that these things were flowing, I don't know, 230 or 240 or something when stock ones were ported. The trick flow version flows quite a bit more than that. And so you can make, I think, there's much more power potential with the trick flow, especially the CNC version of that trick flow head is very good. Because as we know, the head flow is one of the determining factors for power output. So that's very important. It's always nicer to have a combination where you have like an overabundance of head flow than all the other things that you do to it make you look like a hero, because it's got, that's why the LS responds so well. It's like, hey, I've got everything else. If you could just throw some cam timing at me, then I would be really happy. So let's see what you guys got going on this morning. Our poll is still at 73%, and I'm scrolling. Bends do matter, but not as much as you think. Michigan's in the house. I beat everyone to the like button. That's what I want to hear. We need more likes. We got like 33% likes here going on. Come on. Intake bends. I want to see some tight corkscrews. I think people would be surprised at how bad you can make the intake if the runner length is right. That it works pretty well. Look at a tune port manifold. I just hope everyone hits the like button. You got it, right? Richard, I always had a question. What Boost Mobile does diminishing returns typically start in? Air wants to go straight, the path of least resistance. Does anyone know the stock compression ring package material on a 5.3 LS? It mattered with the carb intake on the 5.7 Hemi on Engine Masters. What, having a turn or not having a turn? The Hemi has the same kind of problem as it has that flat flange for the head. Yeah, Bigfoot, I didn't I didn't get your Boost Mobile thing. I think intake port and valve angle would determine my choice. Heading north on 95, no Bigfoot sightings. Just being funny today, no competition on the like button. Freedom of choice to hit or not. No, there's no freedom of choice. You have to do it. It's mandatory. Good morning, Richard. What is more important, engine fuel type, octane, or nitrous enrichment fuel? You can run nitrous with pump gas. We do that all the time. You can also run it with E85, and you can also run it with race gas. I think people tend to do that on bigger shots when they try to run race gas in it. The safest bet is to run race gas with the fuel going into the motor. If it's like a really high compression motor anyway, you probably would be doing that. And then to also have it in the E85. The next safest thing would be to have just race gas in with the enrichment with the nitrous. And then the least safest would be to have just pump gas in both of them. You might be able to hear Milo snoring. So I let my Cutlass go. So I might let my Cutlass go. I took my son to school, and today, and a guy followed me home and begged me to sell it to him. I asked him what he was offering, and it was a lot more than I think it's worth. Is that what motor's in the Cutlass? Could a bend improve swirl for better power? That's possible. Air shouldn't change direction more than 15 degrees at a time. The big question is, I don't need to just love it. I'm not sure it would be able to find another one that's nice and has some really rare factory options. T, what year is that thing and what motor's in it? Richard, I have a 6-liter LS 862 head, Summit 234 cam, Victor Jr. 850. Will a 4-hole carb spacer get me some low-speed torque? I don't know. It might help the signal better to the carburetor, which the Victor Jr. is not a great. It's not a great intake manifold, especially the Cathedral port one. A Super Victor is a better intake manifold, but a single plane is not ideal, especially with that big a cam. It probably runs decent at the top, but you're leaving a lot of power on the table by not having the right intake manifold on there. Unfortunately, for a carbureted application, there's not a lot of better choices for that. '76 Cutlass Supreme that has a black leather interior, nice Corinthian leather. I've never seen another one with black interior. Sport steering wheel, factory spoiler. If it's curved like the Edelbrock E-Force where fuel is injected at the end, shouldn't have any losses, just add runner length for low end. Beautiful mahogany paint with gold flakes. It's got an R code 350. So what was the power rating for that in the mid 70s? I'm scrolling back. Apparently I did a big jump here. Uh-oh. So we got to get rid of you. Man, how did I get down here so far? Let's see. Love to take my turbo 6-liter to 1,000 horsepower. I have no desire to play with who's the weakest link in my drivetrain. The drivetrain is definitely a problem there. I was looking at the Eliminator electric crate last night. It's only like 281 horsepower. That could be a cool future after a 5-liter. Since I can make ethanol for $1 a gallon, lose no power, I don't have to use much. I don't have much use for solar. I was actually looking for a 75. Richard, would it be wise to use pure methanol? So where are you going to get that? You mean just straight methanol rather than water methanol? A lot of guys do that. Richard, do you have plans to do a 7.3 Godzilla? I don't right now. After the Big Bang deals, if the tune is correct, why does Richard not use a stock bottom end? Rods, pistons only. What decides RPM? I don't really understand your question. After the Big Bang deals, if the tune is correct, why does Richard not use a stock bottom end? Richard does use a stock bottom end. That's what all of the Big Bangs were, stock bottom ends. According to Corky Bell, you lose 1% of efficiency per 90 degrees per 90-degree bend. What if you don't have a 90-degree bend? What if it's only a 45 or a 15 or a 12? I was asking at what boost level typically does diminishing returns begin to impact power production? I think you're asking the wrong question. You could keep raising boost until the flow rate of the turbo goes away. So at some point, what you'll have is not that you won't be getting any more power per pound of boost. You should get to a point, if you haven't reached diminishing returns on the hot side, you'll reach a point with the turbo sizing that it won't be able to supply. It won't be able to continue to increase boost. You'll have a decreasing boost curve because it can't support that flow level anymore. The like button is free for everyone. Looking forward to the 302 LT1 build. That would be cool. Richard, what runner lengths are you planning for the 2.2, shorter or longer? I'm going to have both. I can already tell you that shorter than what the one piece and the two piece are probably not going to do anything unless you want to run a lot of RPM. And I don't know that we have enough head flow, and unless we have a custom cam, we don't really have enough cam timing to do that either. But the log manifold already has a really, really short runner length. It's just not a good design intake manifold. But hopefully we're going to find out all that stuff. But I think I can make it so that we have something that's like 3 or 4 inches, And then something that's like 12 or 15, we could go out that far. I just want to know what the best intake is for a Turbo 5.3. Please look at all the intake videos that I have up and you can figure out which one you want. There's not a best intake manifold. There is you deciding what RPM range you want to run and then picking your Turbo 5.3 cam and intake manifold. And well, first, as we said, pick your power level. How much power do you want to make? And then the turbo is going to decide that. And then now, without worrying about what the best intake manifold is or the best camshaft or any of that, if you have that turbo, can you make that power with what you have? Probably so. If you can't, then just put a cam and springs in your wrecking yard 4.8 or 5.3. There's not a best intake manifold, and there's not a best camshaft. Sanford, when a Richard Older video pops up, I hit the like button before the video even starts. Everybody should follow that. He really has some good advice there. Does a Holley intake make a difference over a truck intake manifold? A Holley makes about 15 different intake manifolds for an LS, so you got to let me know which one you're talking about. And is it an NA motor? Is it a turbo motor? What is it? How much boost can an OEM 5.3 truck handle before braking? I know guys have run 30 pounds on them, so it's somewhere more than that. I'm going to have Hogan make an intake manifold for my 671 inline 6292. Will they figure out runner length and design? That's an interesting question. I don't know if they will. They may, a lot of times, intake design, a lot of times that we talked about earlier, is not about optimizing it for the runner length, because the blower has no effect on what RPM range the motor is going to run at. The intake manifold and the camshaft does, but it also has a lot to do with packaging. So it doesn't make any difference what runner length you need or you think you should have. If it doesn't fit in your engine bay, then that doesn't work. And ultimately, you get to decide that how much RPM do you want to run this motor at? Like an inline 6-cylinder 292 is not going to be a high RPM motor. So a longer runner length is probably going to work. And on that motor, and even making all the runners the same, I think would be a kind of a critical thing. Snafu, I wrote that unclearly. Why and when would you not use a stock bottom end? I would not use a stock bottom end if I was trying to do like mid 4-digit power levels and have it continue to work for a long time. You'd at least put rods and pistons in it. But lots and lots of people running around at 1,000 horsepower and less in their cars with stock bottom ends, as long as you have ring gap in them, and it works really well. Darren Morgan showed in a video that intake that has an S bend will create turbulence. TPI does that. Does the length of runner affect CFM? Yeah, usually the longer the tube, the less it flows of a constant diameter. What stall speed should I pick on my 4L80 for my LQ4 Truck Norris cam springs? You can run a Truck Norris cam in a 6-liter with a stock stall, with a stock converter, but probably 2,500 or 2,800 would be fine. I bought my Cutlass from the original owner. It only has 53,000 miles on it. What should I do with my 68 Camaro? It has a 355 with an M22 rock crusher. I'd like to get 650 to 1,000 horsepower. Well, that's a really big range between those two. And I didn't read your last word, otherwise I wouldn't have read your comment. Nimble, I have the same setup, but a sloppy stage 2 cam. Ryan Jans at Tampa Performance spec a 3400 stall converter, but you watch this video, stall isn't really what you're looking for. Just one piece of the puzzle. Yes, Tom, I do. So we're down to 64% saying that they would pick the straight design over the curved design. 36% saying no. Richard, would you rather stroke a motor or make it rev to achieve the same horsepower number? Are those the only two choices? Can you just keep it the way that it is and improve the airflow and the cam timing? I'm running a boreless stack injection system on my big block, 398. I've been debating installing screens and filters for dirt and other impurities. Do you have any ideas on the potential power loss? Yeah, the potential for power loss on a stack injection with lots of the filter systems is a lot. You can lose a lot of power with those. You have to pick the right ones. I don't know what those are. If anybody has any recommendations for filter setups for stack injection. The things that I don't like is none of them really look very good. I know that when the trophy trucks use stack injection on their motors, but they use a big common plenum with a big flat filter that has lots of surface area. And so that the stack injection is still working like the stack injection, and that there's no, they obviously have to get a lot of filtration because they get sand and all kinds of debris in doing what they're doing. But they also want to not hurt the power that much. And their setup actually is pretty cool. And they're trying to grab their air from inside also. But that's not usually feasible on a regular kind of vehicle. Why do you feel the Gen 3 Hemi is looked down on? I don't think it is it? I don't think the Hemi, the Dodge stuff has ever been as popular as the GM stuff has for whatever reason. But the Gen 3 Hemi has a lot of potential. The heads are amazing. They flow every bit as good and probably in some cases better than the LS and stuff does. So there's lots of potential there. It does the same thing. If you put a camshaft in a Hemi, it makes a lot of power. Eric, should I buy short travel lifters to go with my truck Norris cam? That camshaft doesn't need that. Thinking I might do 475 stroker kit for my Mark 8. Would you run flat top pistons with a 4.3 liter LT1? I wouldn't. Those two wouldn't be my choice. I wouldn't put the 4.3 heads on there. The factory heads are not that good. I would put an aluminum head on it, but I wouldn't run a dome piston because it hurts flame travel. I would actually mill the head to maybe get a little bit more compression or play with the gasket thickness. And I would actually rather have less compression and better flame travel than a dome piston. Do you know what the head flow numbers are for a Magna motor? They're not very good, but I'm sure that Stan Weiss has stuff on his channel for that. Richard, I have a height issue with my truck intake. That's not uncommon. What intake will be a good replacement for airflow with a 7875 shooting for any intake manifold that you put on your LS with a 7875 is going to make 650 to 700 horsepower. A fast, a LS6, a Dorman LS2. I would steer away from those sniper style fabricated ones unless you really like the way that they look. They just tend to lose low speed power, but they'll make power on the big end though. With stack injection, you could plenum, then plumb to a remote airbox like an EFI car. Yeah, you can do that. The thing about having the box that I described, like for the trophy trucks, is that unless even if the box is big enough, it becomes a common plenum. So it changes the way that the motor works. Is that why you don't like dome pistons for Hondas? Yeah, it does reduce flame travel. Richard, on a stock LS2, if it's a stock LS2 and you're not running boost on it, I would just put factory head bolts in it. Have you tested Edelbrock Hemi heads yet? I have a set of them, but I don't think we did run them on something. I have to go back and look. I don't know that I don't, but I don't know if I compared them to something else though. I think we just put them on something. Have you seen or tested the Edelbrock superchargers? They have long runners. Well, they have long-ish runners, longer than some of the other guys do. And that definitely helps. Runner length definitely helps. I just don't know about I don't know how long they are, and I don't know what the flow rate of the runners is. But it has a supercharger, so it's gonna it's gonna be perceived as working well. What fuel pumps injectors have you had the best luck with? The factory stuff. Any of the 255 pumps we've used a lot of. I don't know that I'm trying to think of something that we've run for a long term in a vehicle. I've run aeromotive stuff in our race cars, and those have worked well. And I've run, what do we run in the Bonneville? What do we run in the Civic? I think we ran a 255 with the Kenny Bell booster pump on the Civic one. Richard, what would an intake runner that changed shape or size with length do? Well, a lot of intake runners do have a change in shape. They'll have taper to them. Brule expected as much as a 25% power loss by running screens, so I thought was to only run them on long distance trips. Does the Terminator X adjust for restricted airflow? Yes, it will, because you'll be running at a different part of the map. So if that different part of the map is adjusted, and you won't be at cruise, you won't be losing that power. You'll only be losing that power on a sliding scale at wide open throttle. So when you're cruising around, there'll be less of a restriction because they flow enough to run the power level at your light throttle angle. Mr. Sampson, what was your intake question? I thought that I answered it. I try to answer every question. I'm scrolling. Why can I never find when I go back, and why is it the one person that I'm searching for, I can never find what they asked? Oh, you commented on me using a stealth intake on my small block Chevy and said it was holding me back. Cam's 235. Is it a stealth RAM intake manifold? I honestly don't remember the conversation, so you're gonna have to remind me. A stealth RAM intake is actually a pretty good small block intake manifold. But if it's a Holly Stealth, is that a dual plane intake manifold? I did a 3V Cleveland years ago with Weber's. It lost 75 horsepower with the screens and foam stacks over. Every time I've tested, we did a lot of stack injection testing back with the classic fuel injection stuff that we did. And then with the side draft Weber's that I had on my Z's, same thing. We tried various things on there, and it always lost power. I didn't ever find a really good set of filters that didn't lose power, and and like I said, all of them didn't look very good. Does anyone make a kit to put an LS into a 77 F100? I don't know. Ricky, any advice to modify a Ford 4.2 V6? Boost you can do as long as you can program your computer. I don't know about the computer on that, but you can always add a turbo to anything. If somebody makes headers for it, you could port the heads, you could have cams made. All of that stuff is going to help. Why does the old Streetmaster Edelbrock small block Chevy intake being single plane produce torque and have low peak RPM power? I don't remember running that intake manifold, but a single plane traditionally makes power at a higher engine speed than a dual plane does. I've never seen a single plane not do that. If it's a very, very small port single plane, they could change the way a single plane works a little bit, but it will just never do what a dual plane does. You ever put a cam in a 225 slant 6? I have not. I have not tested a different cam in a 225. Can plunge volume affect peak RPM in an intake manifold? If so, how? I haven't seen that yet. I haven't seen just changing plenum volume change where the motor makes power. And in fact, I haven't seen it have a big effect on power at all, other than at very, very low speeds when we tested the 462 valve stuff. What intake would get the best performance to 6,500 on the 302 LT1? Probably the stock one. That's probably all you have to choose from on that. Unless somebody still has a Super RAM for the LT1. Or if there is does somebody make a tunnel RAM for that head bolt pattern? I want to get a Vortec 3500, 3700. The 4-cylinder and 5-cylinder versions of the Atlas, is that the one you're talking about? I watched your Hemi video set. I saw you get pretty good power from a Mopar M1. Is that the single plane M1? That thing loses a ton of power compared to a Magnum intake. It's I don't know why you're saying it's not too far off from the Magnum in terms of torque. It's way off from a Magnum. That single plane intake manifold is good for very, very high RPM, but not good for low speed torque or mid range torque. Why in stealth dual plane? That would stop you from making peak power, but if this is going in a boat, that's probably the RPM range that you want to run in, right? Carlos, I'm a bit late. I just finished restoring an 04 GTO, full bolt-ons. Inch and 7/8 headers, no cam, fast. Good. It sounds like it needs a cam in it though. Like to see, love to see a build with 390 FE Ford and the new trick flow heads. To make an adapter to run a small block Chevy intake on an LS. Why would you do that? Excited to see the 3800 Big Bang. Me too. I'm almost at a point where I just have to do another set of heads, I guess. Tunnel ram with injectors and 1000 CFM throttle body. As long as somebody makes a tunnel ram base for that LT1, because the intake bolt pattern is different on that. I'm installing a hood with an acrylic insert over the injection system. Distance from the injector to the bottom of the acrylic is roughly 1/4 of an inch. Rod, I'm having trouble envisioning what you're talking about. I'm installing a hood, so like the hood on the vehicle, with an acrylic insert over the injection system. The distance from the injector to the bottom of the acrylic. You're gonna have to send me a picture of what you're talking about. I'm having a hard time envisioning what you're dealing with there. The Atlas 5-cylinder would be good. Cool. I just want to do the 6-cylinder first. I want to finish that up. If intake runner bends don't matter, then couldn't all runners be made the same length? Intake runners should be made the same length, ideally, and they should, everything about them should be the same if you want power production from every cylinder to be equalized. Lots of intake manifolds don't do that. In fact, lots of production manifolds, if you see over the years, don't have that. Like all the inline 6-cylinder stuff, none of those. Almost none of the carbureted ones have the same intake runner length. Any sort of dual plane or even single plane 4-barrel factory manifold or aftermarket manifold for any kind of V8, very rarely are those intake runners all the same. They're not the same length. Have you tried Phytech systems yet? They've run those at West Tech with that fuel injection, and then also with some of the manifolds that they offered. On the LS stuff, their manifolds are just those sniper style fabricated deals, and we've run those a lot, so we know what they do. And as long as it will stay consistent, and as long as it will provide air fuel and timing, then it works fine. On an ITB style intake, does the distance of the throttle body to the intake valve matter if the total length of the runner doesn't change? No, the position of the throttle blade isn't going to change power. It isn't going to change the reflected wave at all. It just opens and closes. What it does change is, for some people, and this is kind of more of a road race thing, it can change throttle response on going from closed throttle to open throttle. So it can make the thing feel snappier, I guess. I've always been into 5-cylinder stuff. Samson, I think an RPM air gap would be better than that Stealth is, if that was your question. Burns, it does not matter in terms of power. It doesn't matter at all where the throttle blade is. It doesn't. It only changes response rate. The blade has no effect on the reflected wave. The position of the blade has no effect. Does single blade or ported TBI make a difference? Are you, Sean? Are you talking about the Dodge ones? The throttle blade or the throttle body is going to, or the size of the throttle body and or its flow rate is going to affect the flow rate. And if it needs more flow, it will make more power. Rod, I'll put my email address down here. So if you want to send something. Yes, intake runner length matters with throttle bodies. I mean, with ITBs, but not where the blade is. So go ahead and it's interesting that the poll got less and less. Would you pick a straight intake design over the curved one? Kind of transitioned into the nose here. The nose came on strong at the end. We'll go ahead and close our poll. I never paid attention to the 5-cylinders till a turbo 5-cylinder Audi was ripping at the auto cross last event. Sounds good. I've done supercharged stuff on the chassis dyno with the 5-cylinder Colorado stuff. I remember looking under the hood for the first time when James was doing that way back. I'm like, what the heck engine is this? I said, this is a new 4-cylinder? He said, no, this one's not a 4-cylinder. This is actually a 5-cylinder. I'm like, GM doesn't make a 5-cylinder. He said, yeah, count the plug wires. He said, there's 5 of them. Pip, you're not blocked. VR5s are cool too. I would pick a straight tapered. Yeah, tapering can change power as well. You see that in a lot of the tunnel rams, big block stuff particularly. Michael, you voted no. Well, the in all of these things, the question should just produce more questions. Yep, smash that like button. Just don't treat it regularly. You got to smash it. More votes than likes. I know people. That's why we have the polls, because people are all more excited about that than they are about liking. I get no likes. Story of my life, but Milo does, huh, Milo? He's asleep. Where's all the merchandise? I know. I need to do that. I don't know. I for a long time have felt like that people are doing that just to make money, and I don't know. That's not my thing. I mean, it would be nice eventually. Sequential or batch injection? Yes. You can run both of those, either one of those. I have videos up on comparison between those. Carburation, sequential, batch, and then sequential with individual cylinder trimming. There's no difference in power between sequential and batch. And there's very little difference between doing individual cylinder tuning, despite the fact that the individual cylinders were dramatically different. Do you have video comparing a turbo with the same cold sides and different turbo hot sides? I don't. I have done some of that testing. I have done AR changes. And I did that. I have done that on the dyno at West Tech, but we did a really good version of that back on my Del Sol when we ran some T3 turbos from an SVO Mustang, and we ran a 48, a 63, and an 82 AR hot side, and it made a big difference in power. That's the biggest change I've seen, because we were running the turbo basically at its kind of maximum flow rate. So it was, this turbo was making like, I think 350 at the tire or something like that on the B16, and we saw a dramatic difference in the response rate and the power from changing from a really tight, because a 48 is a pretty tight AR, it makes it fairly responsive, but it also hurts exhaust flow. I would buy a wrong cam t-shirt. Yep. When using the Holley dual plenum intake on a 5.3, oh, the cross ram, would you cam for limitations of the intake, or could you cam it for RPM? You can't cam it for RPM, because the intake manifold is not going to want to run. It's not going to want to make power at 7,500, no matter what cam you put in there. The cam can only shift it a little bit, because the cam, the opening of the intake valve is going to determine the initiation of the start of the reflected wave. But the RPM, it still takes a given amount of time for the reflected wave to travel the distance of the runner, and that's going to be a function of RPM. So you can't recam a long runner intake manifold and make it act like a short runner manifold. Smashing the like button versus clicking seems to have no effect. Yeah, but it's got to make you feel better, though. More money, more testing, more builds. That's true. Mexico City's in the house. The type of bends in the runner make a difference in whether it flows fuel or not. Yeah, if it's having to flow fuel, that's definitely a different thing than having to flow just air. 3/4 turbo cam. Yep. I work with research and technology in Cummings. That's pretty cool. Love doing engine diode testing. So you guys get to test cool stuff if you're working there. You guys get to test some like lots of low RPM, big torque, big boost stuff, I would imagine. I'm using a 48 AR T3 hot side with a 45 trim cold on the G10 build. That's probably a good little turbo for that G10. Would anyone not love dyno testing? It does. It is a lot of work. So after you've been doing it for a lot of years or decades, you know, you could get tired of it. You gotta build a brand. Go hang out with Garrett. No, that's not gonna do anything. I mean, he seems like a cool guy. I've talked to him a couple of times, but getting YouTube famous from somebody else that's YouTube famous that's not the direction I want to go. He does a completely different thing than I do. When the Omni gets done, what car are you going to work on next? I have a 240Z, an early 240Z that will get this turbo 280ZX motor. So that'd be the next one I want to get running. The three cars I want to be driving next year one is the working Omni that's all done. The 240 with the 280 turbo motor in it. It's a pre-smog car, so we don't have to worry about that. And then I have a 5-liter Mustang. I need to get that back on the road too. Do bends really matter? They do. They change flow rate, and especially if they're dramatic bends, they can change flow rate. But they don't change reflected waves, so they have an effect. They affect some things, but not other things. I'd like to see 70s to 80s Japanese carbureted four cylinders change to EFI and see what the efficiency would be. That would be more in the car kind of thing to see if you could change fuel mileage. Some of those carbureted deals work fairly well. Like a carbureted CVCC Honda motor works really good. It has really good fuel mileage because it's a stratified charge card, which is kind of cool. And I'm surprised that they don't continue to do that, but do it with fuel injection. That would be a really cool deal. I can't remember what. Oh, the 70s and 80s. One of the things I am going to do with this 280ZX motor when I get it running is I'm going to do it as a draw through carbureted deal. So it will also run. It will also run carbureted. Finishing touches on your Fox body, nice. With a generic chassis, you could put any engine and trans in the chassis down. It would be cool. It would be cool. We talked about that, lots and lots of decades ago about just doing just be like a rail thing that we could have different engines and transmissions in. Or we were thinking just keep the same transmission in, but be able to hook the different engines to with adapters and stuff. And we thought about that, but it's still a lot easier just to run the engine on the engine dyno. Ultimately, it was what we figured. Well, what's the biggest cam you ever ran in any engine? The biggest in terms of like lift and duration would be one of the big block cams that was more than 800 lift and was 305 or 6 degrees of duration at 50. Fuel injection on the 280 is not good. What is not? I'm not using the factory fuel injection on the 280. We're using a Holly. One more minute. It's morning. We had to get going. Yeah, Snafu, I wouldn't mind hanging out with Garrett and watching them race and do the cool stuff. I always wanted to be I want to be the pace car driver for one of his races because I had a car that I wanted to build as the pace car, and so I'd want to be the pace car driver. I thought that'd be cool, but not because I wanted exposure from it. It's just cool to do that stuff. And so getting to meet people that you meet, I don't ever go want to meet somebody because I think it's going to generate views because that's just not my direction. Obviously, what I'm doing is not the most lucrative part or view generating kind of data that or videos that I'm producing. I could do different things that would get way more views and I would make a lot more money. But I'm doing the thing that I love and I like being on the dyno and I like generating this kind of data and I think that's helpful for lots of people. It would be nice if it's helpful for millions and millions of people, but it's still helpful for lots and lots of people, and that's more important. .8 20 valve VW and a good standalone. Those are cool. There's lots of power to be had from those. Probably beating a dead horse, but as a 6.8 V10, yeah, I would like to do that. And I want to twin turbo it just because it's a V10. I'd like to see a collaboration with Rob. I would like to go see Rob. He seems like a cool guy, and I want to do rotary stuff. But again, it'd be more for like if I went down there and met him and just hung out and talked to him about stuff. I would even care that it's on camera. If the guy's a cool guy, that's one of the benefits of going around and meeting some of these people. Is an engine dyno capable of simulating a quarter mile run like a chassis dyno? Yes, there are dynos that will do that. The one that we have at Westech doesn't do that. It's not gonna do gear changes. Think that the V10 needs quads or quintuple turbos. I still have a hankering to do the 8 turbos on the LS too, or as many as we can fit going across. I just want to show that if we have a good running LS, um, how many turbos we can spool, like how many can we keep stacking on there to where, and then what is the effective change in spool rate after we do that? Not sure if you can simultaneously look at your email. I can. Um, let's see. Rod, who is the email from? I don't see anything up there right now. So I'm not seeing. Rod, I'm not seeing anything on my email right now. Would like to see some testing on 351 with a truck EFI intake. I'm doing a torque build. Yep. GT40 heads, 264 cam. All that should work really well, Corey. I'm still looking. Does anyone see a difference in mileage using different types of Chevron or Sinclair Smiths or others? You're seeing a change from 40 miles a gallon to 35 miles per gallon? Something's going on there. Trying to resend. I'll check and see if it's I've got to get going though, but it is time to go. Couldn't you collectively attach all the turbo exhaust housings to the exhaust housing? What I'm going to do is build a big Y pipe basically that goes forward of the engine and then goes all the way across, and then has flanged openings for all of the turbos, and so they'll just be capped, and then we'll have 2 to start out with, and then add a third one and a fourth one, fifth one, and then all of those will go into the same tube that goes into the intercooler. So again, it'll just be the compressor going into a tube, and the discharge tube also will be capped when they're not in use, and then each one will be connected. It's a little bit of building, but not anything elaborate. And so it just allows you to keep putting them on. And then you have a string of oil feed for all the oil feeds. It's not really that It's not really that hard. Aaron, haven't done a 2.3 liter Ford video, but it would be cool. I'd like to do some SVO stuff. Do the SVOs get your Big Brother 2.5? The 2.5 is a good upgrade for a 2.3. I think dividing the cylinders will spool much better. Much better than what? Than this configuration for 8 turbos? Boosted Lifestyle didn't try what I'm talking about. Boosted Lifestyle did individual. He had one cylinder trying to feed the turbo, and that's not. I don't think. I think that's a lot harder to do. The turbo sizing would be critical for this thing because you'd have to. You're talking about having a range of of 8 turbos, so you wouldn't start out with one S475 or S480 and then try to do 8 of those because you just would never. That's not a realistic thing. You also couldn't try one or two T20 turbos because it's just not enough to even feed the motor. So you have to start out with some realistic size turbos. I'm almost thinking that these are going to be T3s, T3 hot sided turbos, some T3, T4 kind of hybrid deals. Some small, it's going to depend on what's small and cheap and affordable from the turbo sizing thing. And so you'd have to have two turbos that would be sized enough to make some kind of reasonable amount of power, like like let's say two 300 horsepower turbos, so it could make 600 horsepower. And so they're going to be, that two is not really going to be enough. So let's say we have a 400 horsepower 4.8 liter, and then we got two turbos capable of making 600 horsepower, and then they're going to be really responsive, and then they could make, they can at least apply like 7 pounds of boost, and we'll keep the boost constant, whatever the boost level is. And so then we'll add a third one. And so now we have 900 horsepower capability, and then 12 and 15 and all the way up. And we'll get to a point pretty soon where the spool rate should go down. So as we start adding turbos, now the two turbos are going to be ultra responsive. But if we load this thing at 2000 RPM, it'll immediately spool those two turbos up. And when we add a third one, it kind of still might. When we add the fourth one, it's probably not going to spool it as well. And then as we start adding more, it's going to get worse and worse, and not worse, but I mean, it is going to get worse. So the response rate is going to go down. The power actually should stay the same. What I think is going to happen is that we just start losing spool rate, and then it comes up at the end and still makes the same power. That would be the ideal situation. I don't know that that's going to be the case, but it would be interesting. Had a ton of oil seal issues. He had wastegate issues. He had boost control, because I think all of his were internally gated too. So there's a lot of things. So he had a lot of issues, and spooling a single cylinder turbo thing is a difficult deal on a V8. If it's just a single cylinder engine, I think you'd have a better chance of doing that. But so he had a lot of issues. It was still a cool deal, and I think it's interesting. I think that this will show kind of cool stuff, and it's it's an 8-cylinder, eight turbo thing on an 8-cylinder or whatever. Have any beat up ugly parts for a 4.3 Blazer? Is it a 4.3 V8 or a 4.3 V6? 4.3 V8, I have some stuff. I need to organize my storage area so that all of that stuff is separated. Gabe, I don't know what Blazer means. You got to tell me whether it's a V6 or a V8. Although I don't think that they ever put that 4.3 their V8 in a Blazer. Probably would have to be a V6. But on that note, it is time to go. I've been here an hour and 20 minutes. That's too long. From now on, we're cutting it off. Rob, I'll check the thing and see. I'll answer you, obviously, and we'll take care of that if I get that email. So we'll see what happens. Make sure that I'm going to scroll back and make sure I put my email address down correctly for it. And when you put it in, hopefully you put one E and it's BE16 and not two E's. So when you put it in, make sure that you did that correctly. I'm just checking back to make sure that I wrote it down correctly, and now I can't find out where I put it. Scroll in. Where's that foolish Richard Holdner guy? I don't see it. Killer B16 at AOL. So make sure you use that. Okay. I'll see you guys all tonight.